First, we import TensorFlow as TF. Then we print the TensorFlow version that we are using. We are using TensorFlow 1.0.1. For this example, we'll create a TensorFlow tensor that will hold random integers between 0 and 20. And the data type is going to be tf.int32, and the shape is going to be 2 by 3 by 4. Next, we create the TensorFlow operation that initializes all the global variables in the graph. Then we launch the graph in a session. Next, we initialize the variables, and now our random int var will have been initialized, and we can see it in a second. So to calculate the max of this TensorFlow tensor along a certain axis of the tensor, we're going to use the TensorFlow reduce underscore max operation. To get started, we have to figure out the rank of the tensor. We do that by running the session and using tf.rank and passing our tensor to it. We see that it is a rank 3 tensor. This means we can use the reduce underscore max operation across 3 dimensions of our random int var tensor. So we have 3 different possible axes we can get the max of. Next, let's print the random int var tensor variable values. Looking at this tensor, we can manually figure out what the max of each axis is visually. However, if you have a much larger tensor than this one, it's better to do it programmatically. So let's use the TensorFlow reduce underscore max operation to figure things out. To make things simpler for us, rather than assigning the operation to a variable each time and then printing the variable to see the result, we're just going to print the result of evaluating the reduce underscore max operation within a session run without assigning it to a variable. We'll start with the first axis. To get the max along the first axis of our random int var tensor, we do the following. We pass our random int var tensor to TensorFlow underscore reduce max operation, and we say the reduction underscore indices, the axis that we want to reduce across and get the max is that one. So we print it, and we see 17, 17, 5, 9, 19, 19, 8, 2, 18, 10, 17, 13. With the reduction indices at 0, we are comparing the first element of the first row of the 2 interior matrices. 17 versus 3, 17. 17 versus 7, 17. 5 versus 5, 5. 9 versus 0, 9. We can do the bottom. For second row, we can do the bottom as well. 18 versus 1, 18. 2 versus 10 is 10. 17 versus 11, we get 17. 3 versus 13, we get 13. So we reduced across the first dimension, so when we check the shape of this reduction matrix, again, we're using the same functionality we did above, we're just passing it to the TensorFlow shape operation. We see that it is 3 by 4. Again, remember, it is a 2 by 3 by 4 tensor, so if we reduce across the first dimension, we basically remove the 2, so we end up with a 3 by 4 matrix. Next, let's reprint the random int var TensorFlow variable values so we can see the values easily. And to get the max along the second axis of our random int tensor, this time we're going to pass in the number 1 as opposed to the number 0. So again, we pass in our tensor to reduce underscore max, and we say the reduction indice is 1, then pass it to our session run, and we print the result. With the reduction indices at 1, we're comparing the elements in the first column and the first matrix against each other, then the elements in the second column, the second matrix against each other, so on and so forth. So 17, 1, 18, we get 18. 17, 12, 2, we get 17. 5, 8, 17, we get 17. 9, 2, 3, we get 9. Down here we get 3, 19, 1, we get 19. 7, 19, 10, we get 19. So on and so forth. We reduced across the second dimension so we can check the shape. We do the same operation here. We just pass it to the TensorFlow shape operation. We see that it is 2 by 4. Again, we started out with a tensor that was 2 by 3 by 4. So by reducing across the second dimension, we get rid of the 3. So we have 2 by 4 matrix. That is the max that is returned. Let's reprint the values so we have them easily accessible. And to get the max along the third and final axis of our random int var tensor, we're going to run the following. Same as before, we pass in our tensor to TensorFlow reduce underscore max. This time the reduction underscore indices is 2. So before it was 1, now it's 2. And you'll notice with all of these indices that because Python is a 0-based index programming language, that this is going to be 1 less than the actual rank of the tensor. So our tensor rank was 3, so this is 2. This is our last axis we're reducing against. So with the reduction indices at 2, we're comparing elements in the first row in the first matrix against each other, then the elements in the second row in the first matrix against each other, so on and so forth. So we have 17, 17, 5, 9. The max is 17, which is what we see here. Then we have 1, 12, 8, 2. So the max is 12, which is what we get here. And then the third row is 18, 2, 17, 3. So the max is 18. Then for the second matrix, it's the same thing, 3, 7, 5, 0. The max is 7, which is what we get. 19, 19, 7, 0. The max is 19, which is what we get. 1, 10, 11, 13. The max is 13, which is what we get. And because we reduced across the third dimension, when we check the shape, doing it the same way as before, we pass in our reduced function to the TensorFlow shape, we get 2 by 3. We started out with the tensor that was 2 by 3 by 4, so if we reduce across the third dimension, then we would expect the 4 to drop out, so we get a matrix that is 2 by 3. And that is how you can calculate the max of a TensorFlow tensor along a certain axis of the tensor using the TensorFlow reduce_max operation.